I welcome you all to this course on circuits and systems. In this course, we're going to start from the basics, so you don't have to worry about any prerequisites for this course. So from basically, we're going to start with charge. What is a charge and why charge, everything. Okay, a charge is given by the notation of coulombs. The unit of the charge is represented in coulombs, okay, and the magnitude is 1.602 into 10 to the power minus 19. Why we say this magnitude is because one electron charge is equal to 1.602 into 10 to the power minus 19 coulombs. But an electron will have a negative charge, negative sign here, but in general a positive charge is going to have this much of coulombs. Okay, this is the unit of a charge. Okay, and one more thing we need to understand is we know that like charge is going to repel each other. For example, a positive and a positive charge is going to repel each other. Why? Why? Because this positive charge present here is going to exert one force upon the another charge present here. Or we can say there is a kind of force or a field present around every charge. So we have to understand there is a field present around every charge. So that field is going to produce a force. So this charge is going to exert some force on this, and that force is actually a repelling force. So it's going to repel this charge away. Similarly, this charge will have a force upon the other charge present around it. Because there's only one charge present around this, so this is going to exert a force only on this. And because the magnitude of these two charges doesn't match, so that's going to be a repelling force. While here, it's a positive charge and it's a negative charge. So unlike charges are going to attract here. So there's a force on these two charges as well, but it's going to have an attracting force. Okay, and the magnitude of the force can be given by Coulomb's law. Okay, what is Coulomb's law says is that whatever the force these two charges are going to exert on each other or going to exert on some other charges present around them is proportionate to the magnitude of the charges. So suppose we call this one as Q1, or else for example a Q1 charge is present here and Q2 charge is present here, and they're separated by a distance of r, then the force exerted by Q1 on Q2 will be proportional to this one, the magnitude of the charge Q1 times the magnitude of the charge Q2 divided by the distance squared. Distance r. R is the distance between the Q1 and Q2, the placing between the Q1 and Q2. Okay, this is what we say from Coulomb's law. Coulomb's law explains the force, how much will be the force, or on what the force is going to be dependent on. That is what we're going to get from the Coulomb's law. Okay, similarly, suppose these two charges are 4q and minus 5q. That means what? They're opposite in sign, right? The polarity is different. So the opposite charges are going to attract each other. So it is going to be an attractive force which is going to be produced in this scenario of 4 and minus 5. Okay. In general, in nature, we cannot create a charge or we cannot destroy it. So that's what we say a law of conservation of charges. That is, charges can neither be created nor destroyed. Okay, so that makes the law of conservation of charges. Next, electron is a negative charge, that is minus q. As I told you in the previous slide, that 1.602 in 10 to the power minus 19 coulombs is equal to one charge. So electron is nothing but a negative magnitude of a q, this electron. Okay, and here why the importance of q coming in circuits is because when the charges flow only, the current will be produced. What kind of charges need to flow? The electrons, the electronic charges must flow in a circuit to produce current. Suppose this is our circuit, the flow of electrons in the circuit is going to give us the current. Okay, and one more thing, the flow of the electrons and the flow of the current is in the opposite direction. For example, here in this circuit, the electrons are going to flow from the negative terminal to the positive terminal. So negative terminal basically means the starting where the electron is going to start. So direction of the electrons is the orange color line on the outer side. So electrons are going to start from here. The negative terminal is going to give the electrons. So electrons are moving like this, while the current is coming in this direction. So from this we understand that the direction of the electrons and the direction of the current are opposite. Okay. And one important thing we again saw was that the flow of charges. What charges? Electrons. These electrons are what? They are the negative charges. So the flow of these negative charges produces current in any circuit. And the direction of the current is opposite to that of the flow of the electrons. So this is about the basics of charges. And thanks for watching.